Okay. I will talk about the data that this is based on, and how you could start to implement those changes, and what the effects that have on your team and you individually as a developer. So, the industry standard. So, we're software developers, right? We do features, we fix bugs. So the usual development approach is whenever there's a new feature, the developer branches out from the main line. There's a feature branch. Then Z develops for hours, days, weeks. And once this is done, there is a review. Someone else, another developer, is going to look at the code, and there's going to be, probably the first remark is going to be, you forgot to do the tests. Then you do the tests again. Okay, I'm just doing the tests, just in a few hours or days passed. Then there's a lot of reviews, a lot of remarks that you have to fix. It's going back and forth, and at some point, your feature is ready for merge. Then it goes to the mainline, and subsequently will go to the production system. For whom of you is this your default way of working? Nice. Okay, the second and last audience interaction before the Q&A. Who of you had to, well, no, let's phrase it differently. Who had reviews to do in the last week? Reviews of other people's code, your colleagues' people's code. Okay, the vast majority. Who of you enjoys doing that? Okay, good. So, as I described the industry standard as we have it, we could look at this in a different way. So we could also say, okay, that the development is done in isolation from your fellow developers, from the continuously changing mainline, and also the tests are written after you've completed the feature, right? So you don't know really if your feature is testable at that point. You might need to rework everything. All in all, the feedback is there's isolation, as I said, and so the first code exposure really is when you put this up for review, when you have your merge, when you put up your merge request, and this is a workflow that's optimized for the single developer to do their work, and we thought we were developing as a team, right? So it was actually a very interesting talk before on mob programming that has the very same aspects here. So this is optimized for the single developer, but we were supposed to work in a team, right? So what is the issue with this? Let's go here. Okay. So the problem with this is that we have late feedback. We only get the feedback when we have the review. So the design, the code design that we did, or that the isolated developer did, is going to only be reviewed, the feedback you get only after hours, days, weeks of work. You also have late feedback for testability, because, well, most of us just write the test after the feature has been completed, if you even write test at all. And any change that you have to do later on, the later the feedback, the later you fixed it, the more it costs you. So that the cost curve, the cost grows exponentially over time. The longer further away of the original development you identify the bugs, the higher the costs to fix those. Also, you lose a lot of time for context switches, because you are finished with your work in the feature branch, right? You put up the merge request. Someone else is going to have to stop their task and have a look at what you did. Meanwhile, you switch to something else, context switch, another task. And then there goes the cycle of review comments, fixing those, going back and forth. And every time you have to do context switches. That takes a lot of time. So all in all, this is just to optimize for the single developer. So how could we do differently? How can we address the issues that we have? The issues being late feedback. So what can we do? And all of these techniques that I'm going to show you today, they're not new. In the text for this talk, it says there's a new technology or a new approach there. This is all very old. Pair programming, this is from extreme programming from Kent Beck. That's way old. So to counter the late feedback issue, we can use pair programming, right? So you have a continuous review. You can actually ditch the review of the merge request yet, because you have already a second pair of eyes on your code. You develop that together. So there's continuous and the fastest feedback that you can get while you code together. The next thing is that you could use is test-driven development. That means that you write the test first. You write down the behavior that you expect, then you do the implementation. Automatically, your code is going to be, your code is testable. You don't have to adapt it on later on because you found out, oh, I can't test it like this. It's highly coupled. Then we have the issue of the integration feedback. So do we know that we can really check in our code into the mainline, or will it give us code conflicts? Most probably. So we integrate regularly. We integrate continuously. What does continuously mean? It means several times a day. That is how often your mainline changes, and you should integrate that continuously, at least daily, that is. All of that requires you to think in small increments, because how are you going to integrate a feature that takes you 3 days? How you want to check in those changes multiple times a day? You have to break down. You have to be able to break down your functionality in smaller increments. I can give you as an example that we just had recently. How you could break down functionality. So we're an e-commerce agency, right? So we have product detail pages with prices on them. And there was a condition to showing the prices. The product needed to be shortlisted. Only then you would be shown the prices. Otherwise, there would be a button. So to request the prices. So there's a condition in the front end, right? And you had to know if the product was shortlisted. The rule was, if the product was shortlisted for this customer, for the logged in customer, if the customer has bought this product within the last year. So you have the front end part, you have the calculation logic, and then you have the fetching of the order history from the database. So usually the junior developer would go create a new branch, fiddle a bit with the database, having something in the front end, some switch there, and then it's going to be the calculation logic in the middle. At this point, we already have identified. At the end, we will know what the increments, what the small components are, right? But we are all experienced developers, right? So we know the general approach that we want to have here. And so we can already see, okay, there's going to be front-end part, and there's the calculation logic. So I start with that, just a small calculation logic. This is the class. And again, we write the test first, so let the test drive our implementation. So we have a class that just takes the order history, and then it just returns true or false for a given product identifier. That's it. Only this small class. You have a test for it, and you can already commit that and push that to main, because that functionality doesn't break anything. It's already usable. It's not really used in the code base so far, but it's already there, and it works as expected. And then you or someone else could in parallel start with a database query, and the front-end team could already start with using that switch in the front end, right? And all these small steps that you take here, they shouldn't take more than a few hours. And then those small steps you can always integrate continuously into the main line. But that requires you, and that is the hard part, to break down your functionality that you want to do into smaller increments. You have to be able to think in smaller increments. Okay, so there we have the 3 techniques: pair programming, test-driven development, continuous integration. And all of that together is roughly what we call trunk-based development. There is no feature branches anymore. All the small increments are just integrated directly, frequently into the main line. Now you might say, okay, this is a very theoretical approach, putting all these techniques together, calling it trunk-based development. Who does work that way? A lot of companies, actually. So the data here, now let's start with the data. So this is a state of DevOps report from Google. They measure the performance of teams. So they have 4 measures to identify the performance of a team. The first thing is lead time. The study. This has been ongoing for 7 years with 32,000 professionals. So this is a very grand study. So these measures to measure the performance, they have lead time for a change. That means how long does it take for your commit to go to the deployment to the production system. Deployment frequency, how often can you deploy to the production system? And the change failure rate. How often does the deployment yield defects on the production system? And they found that the high-performing organizations or development teams, that they have implemented trunk-based development. That's the statistical relation. So that means these developers or teams, they work in small batches or increments, as I said, and merge their work into a shared trunk frequently, at least daily. And so this is what they found. This is what they have these groups. So the elite organizations have trunk-based development. So there you have that statistics. Let's have a deeper look at the technique of pairing. Why is this better? Why do we get this faster performance? Studies show that pair programming. Oh, do you need to explain pair programming? It's 2 developers, 1 problem, 1 mouse, any number of screens, 1 problem. You code together. So you might want to say, okay, 2 developers solve the same problem. That's going to just take twice the time, so 50% more time. No, it does not. It does take you 15% more time. Now you might want to say 15% more time for the same problem. That would just take longer if I would do it individually. Yes, but you also get 15% less defects. And you identify these defects right while you code. You don't have to fix them later on, which is way more expensive. So these 15% less defects that you have, that you don't need to fix later on, this outweighs the 15% more time that it takes you to develop this together. Also, as I said, if you have the pair programming, you have the ongoing review. You don't need to have this merge request and to review this and this back and forth and all this context switches. You can also forget about that time. It turns out it's more enjoyable. The human is a social being, and you also get higher quality of the code. They measured this in lines of code. The same problem was solved with less lines of code, but if you think about it, it's 2 brains on the same topic, so you have more brain capacity to come up with an even nicer solution. So that was about pair programming. What are the benefits? Let's have a look at test-driven development. Test-driven development again means you write the test first, and then you do the implementation. Once the test passes, you know you're done good. So studies, well, there's this one meta study that had a look at roughly 10 studies that had a look at comparative studies, compare test-driven development teams as to the legacy approach. And again, we have a reduced defect rate. IBM and Microsoft reported, IBM reported 40% less defects, and Microsoft reported 60 to 90% less defects as compared to the legacy approach. That is because you cannot write bad code that's testable. You have low coupling, you have modularity, you have to use dependency injection. Otherwise you cannot test your code, and that automatically makes the code better, right from the start. And that means you have prolonged maintainability, so it's easier over a long period of time to modify and adapt your code, because it's not that entangled. You are at forest, you cannot entangle it that much. So yeah, so reduced defect rate, and the overall quality is better. So these are the techniques: pair programming, test-driven development, and continuous integration. The big picture is that you need to have some technical support, automation. These tests that you write, that you always start with first, right, from the test-driven development, those tests should be running continuously on the so-called, the continuous integration pipeline that checks runs all the tests continuously of your mainline, so you know that your product can build and all the tests pass. For the local environment development, it is recommended to have a pre-commit talk, so that you're not even able to check in code that's not working. Right, all the tests need to pass, so that's where you get your certainty. So let's say now you're intrigued. The numbers are good. Less defects, faster development, prolonged maintainability. We want that too. How do we get that? And this is from the experience that we have in our company, where we introduced pair programming. We didn't have trunk-based development in our mind at that time, but we introduced pair programming. And there is, you can talk about this once, like in this talk. It doesn't help. You can't convey the benefits of all those changes, because you talk about years of engraved behavior, right? I develop my code alone, I do a merge request, then I write the test. And this has been working, right, for years. It still does, but it's not optimal. And if you want to convince your colleagues, it's only by their personal experience. They need to experience the benefits of pair programming. They need to experience the benefits of test-driven development firsthand. So that it's all about experience. That's what I can. What we learned the hard way. So what we did, if we started with pair programming, we roughly have that as a default in most of our teams in the company. So the next step to go fully trunk-based development, to get rid of the merge request in the end, is that you introduce test-driven development in mob sessions. So we had this the talk before about mob sessions, very interesting. We started this actually with the ongoing tasks in the team, so what they actually are working on. So it's not code kata or anything. You can do that too, but at some point you need to encourage them to use this on their day-to-day tasks. So this is how we. Okay, so right. So in those mob sessions, so you have pairing already as a default, right? And then you would start the test-driven development experience. And you would allow your teams to, you need to discuss, you obviously discuss this, to break down the feature into smaller increments. And then you start with a test, for the very first increment. Once the test passes, you allow the team, the mob, to actually not already push to main, because you know the tests are all green, it doesn't break anything, and it already adds value, right? And it's all accessible for the other developers in the team. That's the team aspect. I will talk about that later. And then you allow, and once you have some experience, right? You have some mob experience with test-driven development, you allow also a pair, just a pair, you allow the pair programmers in your team to also, if it's test-driven, so new functionality or bug fix with a test, you allow them to push that to main directly. And then you have it, trunk-based development. There is no merge request anymore, and you have continued, your mainline continuously grows. That's the short version. If you do that, so here's a hint from, if you want to host those test-driven development sessions to learn about it, you yourself will also learn, but to teach your colleagues. Be sure to own the topic, the task that is at hand, and be sure to own the test environment. And nothing breaks the fun of test-driven development if it's really hard and you don't know how to write the test itself. So you should know how to set up the tests, know the capabilities of your testing framework. Take your time to discuss how to break down your functionality. That is what differentiates, if you ask me, the real good developers from the senior developers. That you're able to break down your functionality in smaller increments, that you can think in that way. And then you have discussed the smallest increment. Go really slow with the increments. You continuously will fall back to your old behavior. Okay, I know how this works. Let's just skip some steps. Don't do that, because you will miss out on the process. So try to be really, at the beginning, try to be really strong about the steps. Switch a lot. That's something that you have in these mob sessions, as you should do. That's it's so that everyone is in the loop and everyone is active. so no one gets well. That's a multi-session problem actually, that people might doze off if they're not typing or have to think along. So you would. But what we did is, so we picked some small pairs of actual teams, and we grow that, and then you can encourage a discussion to the team. And at some point, there should be a majority of developers that have had the positive experience about test-driven development, and then this should become automatically a default in your team. So, but it's not all nice, right? As I said, this is a paradigm shift. So you talk about years of engraved behavior, and there's some. It's actually funny because there's this fear of losing the control over, okay, we're not going to have merge requests. Who's going to control the quality? Who's going to control that this actually works? The tests will do that. And you can and you have them automated. They run continuously. You don't have to wait for your fellow developer to review this. You have this ongoing review, and the tests all do pass. So you're pretty certain that this is going to work. And then there's this fear of pushing to main directly. That's a very funny part, because when you do these test-driven development sessions, just when you're trying that out, you find that you have the test, you have the function, it's green, the functionality obviously works. And then you say, no, let's push this to main. And it's like, no, we can't do that, we can't push this to main. Why not? It doesn't break anything. And then they do, and then it's like, oh, that's really breaking a wall when you do your first push directly to main. It's actually funny, because every time it's the same reaction. Oh no, we can't do that. We can't do that. And what you also need to be aware of is that and yourself, you will do that. That you would be reverting to your old behavior patterns, right? Because we know this works. The old way, the single developer approach, that does work. And you know how to work on that way. That new approach, that's hard. And you have to keep encouraging yourself and your colleagues to, yeah, let's start with a test first. Let's pair on this one. Let's do a small increment first. Let's touch every file at the beginning. So if you have all of what's in it for you? So trunk-based development, no reviews anymore. As the statistics show, you have a higher quality code just by your code being testable. You can't write bad code that's testable. And you get a truly cooperating team. With these small increments, as I said, you have this calculation logic, right? That would take the order history and calculate if product is shortlisted for that customer. You have that calculation logic tested, you pushed it to main. Already at that point, the front-end team can already call your module there. It might return a default value for now, but the connection is already there. At some point, you're going to actually return a value, then you're going to add the database query. You're going to actually fetch data, and then you get the real value. But the connection is already there, so you can work in parallel on this feature because the interfaces are clear. So that enables you to continue other people's work. Also, as we have with pairing, there's always another developer that knows what's going on. And so like you have there's people who only work on 4 days a week, and then on Friday, that this feature branch is lying there. No one can continue it. Oh, at the end of the sprint, that's stupid. But if you have pair programming as a default, then there's always going to be a developer who already knows how to continue that. So we have increased confidence through tests, way less time wasted on context switches, and a generally faster development. You actually work less time, since you have less bugs, you spend less time on bug fixing in the future and way more on features. That's what you get from a business perspective. So what's in it for you personally as a developer? If you do test-driven development, then you will have the continuous endorphin rush of green tests. Every time you run that test, you have constant closure, right? The test, it's a small thing, but it's continuously. It's all the satisfaction of this functionality works. It's done. I don't need to think about it anymore. I can just use this now. It's not an open end in some gigantic feature branch that's, was I really sure that this did work? No, you know, the test passes, you know that. You have the collaboration. It's more fun to work this way because there is no, shit, I have like too much requests that I have to review. Ugh. Ugh. No, you can just deal with your own features, all your own bugs that you have to attend to. So that's more fun. And you get to go home early. Why is that? Any idea? Sorry? Yeah, you do. I definitely sleep better at night when I know that the tests do pass. Well,
coding partner is gone home already because you started early.
That could very well be. Yeah, you just. No, this is an aspect that just came up when we had this in our company. When we had two teams. The first team needed a bit of pushing, but after some weeks, or actually in the first week of when we said, okay, we're going to do trunk-based development, after a week, this was the default. So we tried it and it was immediately the default. But what is, and the problem that you get is, or this, well, it's a problem, yeah. Pair programming is a very draining practice, right? If you work alone, there is like a lot of possibilities to procrastinate. There is Heise, there is Golem, there is a notification on your mobile phone. All right, you can't do that, you shouldn't do that when you're pair, right? When you're pair programming, you're continuously working, thinking along one topic. You should repeatedly do Pomodoro breaks. But at the end of the day, you're drained faster. So like if you really work and concentrated after 5 hours, some people say 5 hours or 6 hours, you're done. Your brain is done. Now, anything that you do after this threshold is going to be mediocre work. Stuff that is neither going to work, and we all know the effect of that we're trying to fix something and it's really getting late, and the next morning you're like, the last 3 hours of the last 3 hours of the last day totally wasted because you were over your capacity, right? And that's if you have a company that's actually selling their own products, so you don't have to sell hours to your customer because they want you to book 8 hours a day. Though everyone knows that no one works 8 hours a day, you're pretty much screwed. But if you have your own product, and you know and as I showed, you deliver the same feature set in the less time because you don't have reviews anymore. You can skip that time, and in the mid run, you have less bugs, so you get faster, you get more progress, you're faster, and that's why you get for the 5-day output. When you just concentrate, when we were concentrated, you just get the same output that would you have with 8 hours of procrastinating and doing this and that. Yes. Oh, there's a conclusion slide. All of these techniques in the end make you, it's not trunk-based development in itself, but the techniques that you need to make it work already make you a better developer. Individually, they require you to be a better developer. That makes you also a better team. You will have more fun at work, but you have to take the leap to make that experience. And that is all. Thank you very much. Are there any questions?